Good afternoon, everyone. And today is Wednesday, October 19th. So today we will talk about sessions 4.5. Oh, let me make this bigger. So, okay, so it'll be bigger. Yes. Awesome. Okay, so today we will talk about section 4.5, properties of logarithms. And then for Friday, we'll talk about 4.6, exponential and law equations. And then the Monday, we'll talk about 4.7. So this week, you don't have any quiz, but don't forget to do your homework, okay? So our second homework set, okay, is due on next Friday. So next Friday, you want to, or that day, yeah, that day, homework 3.5 to 4.7 must complete by the Monday, October 31st. Okay, so do your homework, and if you have questions, you can email me, or if you want to post them right here, this question sheets, then if we have time, we can go over them together, okay, in class. Right. Okay, so let's see. I already graded your quizzes. Let's look at your quiz 4. So quiz 4, we have this rational function, and we want to find the x-intercepts, the y-intercepts, and all vertical asymptotes and horizontal asymptotes, and sketch the graph. Okay? And the problem asks us to show all our work. Okay? So show all our work. Let's see. So, let's see. Part A. To find the x-intercepts, we set the numerator. So given this rational function, we factor the numerator and denominator. So numerator can be factored as x minus 3 and x minus 2. Right, everybody? And the denominator is already a linear factor. Okay, so x-intercept, we set the numerator equal to 0. That's why we can have x minus 3 equal to 0, or x minus 2 equal to 0. And therefore, x equals to 3, or x equals to 2. And remember, x-intercepts, they are points, okay? X equals to 3 and x equals to 2, they are vertical lines. So when you answer x-intercepts or y-intercepts, give me points, not numbers, not equations. Is that clear, everybody? So points, parentheses, 3, comma 0. Okay, parentheses, that's a point. And this point 2, comma 0. So that is for the x-intercepts, and it works 4 points. And then the y-intercepts, we plug in x equal to 0, right? We plug in x equal to 0. We get 0 squared is 0, minus 5 times 0 is 0. Do you see the numerator? We have 6, everybody? And the denominator, we have 4. So 6 over 4, the common factor is 2. So we can cancel the common factor. We get 3 over 2. So that's why the y-intercept is 0, comma 3 half. So far so good, everybody? Again, x-intercepts and y-intercepts are points. Give me points. Point is parentheses, x-coordinates, comma, y-coordinates, and then the parentheses, okay? The equation x equals to a number, this is a vertical line, right? Vertical line, x equals to a number. And the equation y equals to a number is a horizontal line. All right, everybody? So therefore, you want to answer your part A and part B in terms of points. Okay. And then part C, find vertical asymptotes. So we set the denominator, okay? the denominator, to find the domain, so the denominator cannot be 0. And then we solve for x, right? We move the 4 to the other side, so we subtract 4 on both sides. We get 7x is not equal to -4. And then we divide both sides by 7. We get x not equal to -4/7. Right, everybody? And some of you just say, oh, so we have a vertical asymptote, x equals -4/7. That's not enough, because you want to show what is the behavior near the vertical asymptote. That's why it goes to positive infinity or minus infinity. So you have to show when x goes to -4/7 from the right. What happened? Well, in this case, you will have 7x plus 4 will go to 0 plus. Yes, everybody? And do you want to plug in the original form or the factor form? The factor form. Okay? So say it. Factor form. Factor form. Right? Say it again. All of you. Factor form. Yes. We want to plug in the factor form. That's why, negative minus negative. You don't have to calculate what this number is. You just need to know this is a negative number. Okay, everybody? So, and here, you see, this is a negative number, and this is a negative number, and the denominator 0 plus. Therefore, two negative numbers, we get positive, right? So, constant over 0 plus, we get plus infinity. Yes, everybody? So this is when x goes to -4/7 from the right. And then next, we check when x goes to -4/7 from the left. What happened? You see the 7x plus 4 will go to 0 minus, but all the other stuff remain the same. Yes, everybody? So that's why, negative number times negative number over negative number. You see 3 negative signs? So that makes it negative. So constant over 0 minus and 3 negative signs. We know the answer is minus infinity. Right, everybody? So that is vertical asymptote. So you not only need to find the vertical asymptote, but you also need to check when x goes to that number from the left and from the right, what happened to your y? Because our final goal is to sketch the graph. So you would need to know this information, then you can decide whether I should put the dots at the top or the bottom. Right, everybody? Okay, so that's why this set, we have 8 points. And then here, the horizontal asymptotes. So horizontal asymptotes, we look at the dominant term of the numerator. Yes, dTn, dominant term of the numerator. That is, we look at the original form, right? Dominant term is the highest power term. Do you see the highest power term? On the top is x squared, and then the bottom is 7x. You see that? So that's why dominant term of the numerator is x squared. Dominant term of the denominator is 7x. So many of you just tell me no horizontal asymptote. That's not enough. You need to show all your work why we don't have horizontal asymptote and what is the end behavior. Okay? So that's why you say as x goes to infinity, the y behaves like, look at the dominant terms. So x squared over 7x. One copy of the x cancel, but we still have an x on top. So x over 7. Now you see when x goes to infinity, we get infinity. The y goes to infinity over 7. Oh, so Monday, we don't have class. Let me pause that. See? Is this the correct one? Yeah. Thank you. Yes. So, yeah, when x goes to infinity, infinity over 7 is infinity, right? And when x goes to minus infinity over 7 is still minus infinity. Yes, everybody? So, many of you didn't show that. That's why you lose some points, okay? So, show your end behavior. Now, based on those information, we can draw the graph, okay? It has x-intercepts 2 and 3, so we plot the 2 and 3. It has the y-intercepts 0, 3 half. Okay, plot this point. And when x goes to negative 4 over 7, negative 4 over 7, right here. So by the way, on your graph, please label. Okay, I told you many times, so you don't need to put a lot of bars. Don't need to do that. Okay, you just plot the important points, but label them. So the important points are 2, 3, and 3 half. Okay, and this is minus 7, 4. Label them. You don't need to put a lot of bar here. Okay, everybody? Do you hear that? Yes? Okay. So when x goes to this number from the right, y goes to infinity. So that's on the right side, infinity, top. That's why you put a small dot right here on the right hand side and the top. Okay? And when x approach this number from the left, y goes to minus infinity. See? Left, bottom. Yes, everybody? And here we don't have horizontal asymptote, but you see the y goes to infinity. Infinity is top, okay? And when x goes to minus infinity, the y goes to minus infinity, the bottom. So you connect the points together. So this point, connect this point, connect this point, and go to infinity, go to the top, right? Here, connect this point, go to minus infinity, so go down. Make sure you do not cross the x-axis because we should not have any x-intercept right here. So do not touch or cross it. Is that clear, everybody? So this is how we do the quiz. Any questions? A quiz solution? Okay, now let's see our mistakes. We learn from our mistakes. So I hope that okay. So now you see the requirements. Every step we have points. Okay. So make sure you show all your work in the exam to earn those points. Okay. So here, why this is the x-intercept? Why this is the y-intercept? Why this is the vertical asymptote? Why we don't have horizontal asymptote? Why this is the graph? So just the answer is not enough. You need to show all your work. Is that clear, everybody? And remember in the exam, no graphing calculator. So that's why you need to label the important points and sketch the graph. Okay. Show all your work. So here, it passes through this number, passes through those two numbers, and then goes up. Okay, and here like that. Okay. And then here, yes. So the student already approaching this number from the right, but how about when we're approaching it from the left? And what happens? And when x goes to infinity, yeah, y goes to infinity. How about when x goes to minus infinity? Okay, you have to check all of those stuff. Okay, vertical asymptote, you check from the left and from the right. And then horizontal asymptote, you check both directions, infinity and minus infinity. Check both directions. Okay. And also you want to make sure you plug in the factor form. Don't plug in the original form because the factor form can tell you each factor is positive or negative. Okay, everybody? And so this is 0 plus, and your answer is infinity or minus infinity. Okay, no, haven't finished. Okay. And yeah, keep going. Draw what happened here and there. Okay. So yeah. So don't put a lot of bar. Label them. Okay. So 2 and 3, label them, and this is minus 4/7, right? So you don't need to put so many bars. Okay, because we sketched the graph. It does not need to be very precise, which means the scale not need to be 1-to-1. Okay, so you can have maybe like some of our problem. Maybe your y-intercept is 2,577. Then if you want to show 2,000 bar, then you don't need to. Just put 1 bar and say this is 2,397. Yeah. Thank you. Right. Okay, but label the numbers, the important points. See, 3/2, label that because I can't tell what is this y-intercept. I cannot tell from the picture what is that number, right? And so please don't put so many bars, but label them. That is more important. Okay. And yeah, y, and yeah, show more. Okay. So, oh, yes, we don't have horizontal asymptotes because you see the power of the numerator is 1 bigger than the degree of the denominator. So we have slant asymptote. And this is a perfect way to find the slant asymptote. But you still need to show what happened when x goes to infinity and what happened when x goes to minus infinity. So the end behavior. Yeah, and vertical asymptote is this, but why? And please label the important points. Yeah, also say why. And yeah, a lot of you have like similar mistakes. So see, x-intercepts, they are points, not equation. Equation means vertical line. Okay, so we don't want to put vertical line. We need points. So that's why I answer the points. And here, yeah, what is the end behavior? Because we need this information to figure out our graph. Okay. And then here, yes, y. Show all your work. Label. Yeah, so similar. Oh, the student already gets x/7. So that's good. And that's not equal to 1/7 because our goal is to have x goes to infinity. So you have infinity over 7 is infinity. And if x goes to minus infinity over 7 is minus infinity. Okay? So, yeah. Okay. And then, yeah, so need to show that work. Okay. Yeah, so the graph, yeah, show the end behavior. Yeah, show the end behavior. Okay. And label the important point, show the end behavior, and show more work. Okay. And yes. And just make sure it's more like clear to see, oh, it goes to infinity or it goes to minus infinity. Because if it goes like this, it's hard to tell whether we have a horizontal asymptote or not from the picture. So make it more obvious, right? It goes to infinity or minus infinity. Okay. Yeah, see here, if the arrow is going this way, it looks like we have a horizontal asymptote at y equal to 0. Do you see that, everybody? So make your arrows more obvious. It goes to minus infinity. Here, see, it looks like it's going to approaching the x-axis. You want to show, oh, it goes to infinity. So make it more obvious. Right. Oops. Okay. All right. Yeah, and then here, check your answer carefully. You see, you have a minus here, but then you forgot the minus sign. So check your answer carefully. Yeah, and this is correct. And then you continue. Oh, x goes to infinity. So infinity over 7 is infinity. So continue. So, right. And x-intercept. Yeah, x-intercept, that point, y-intercept, that also points. And don't forget this piece. Okay. And, oh, vertical asymptote. Vertical asymptote. We said the denominator equal to 0. Okay? So that's why this is not 3. X-intercept, numerator is 0. Vertical asymptote, denominator is 0. Okay. All right. So for rational functions, our steps is quite standard. This is the standard steps. So I hope you can remember and understand these steps and practice a lot, because the problem on your exam is gonna follow the similar steps. Okay? So show all your work and follow the steps, and then you can do it. Right. Oh yes, we put in the factor form, not the original form when you find the vertical asymptotes. Yeah, and then show all your work. See? So yeah, so similar mistake, right? Okay. So that is the quiz. Any questions about the quiz? So for those of you coming late, don't forget to look at our recordings for the things that you miss. All right. So yeah. Any questions about your quiz? So our plan is continue with chapter 4. After we finish chapter 4, you can do your practice exams and review your notes, all the class notes and the recordings. And so please make sure you do the practice exams. You know, from the last exam, our practice exam is so helpful, right? In our actual exam. So please do it and use pencil to grade your work and write the corrections. Make sure you know the steps of doing each type of problem, okay? And then follow those steps. And then, okay, try our best. I hope you have a much better grades on exam too. Okay, so, okay, and keep doing your homework daily. Okay, so, right. Doing homework also really help you to understand and see more type of problems, more practice. Okay, so 4.5, properties of the log. Okay, you need to know the following log rules, like your own name. We have the following properties. So assume that P and Q are positive, and then the following holds. So log B, the base B of P times Q is log B P plus log B Q. Okay, so this says that the log, we can break the products into sum. Okay, so if we have a product, we can break it, and now we become the sum. Yes. So how do we prove that? Well, let's call this be x, and let's call this be a, and let's call this be c. Okay, and then what does that mean? Well, this is the log form, but the exponential form, we know, okay, y equals log bx. This is the same as saying b. b is always the base. Yep, b to the y equals x. Is that okay, everybody? So this is the log form, and this is the exponential form. So therefore, here, if x equals to log b pq, that means b to the x, oops, equals, okay, let me save it, equals p times q. Yes, everybody? Base is b, so b to the x is pq. And then this guy tells us what? B to the A equals P. Yes, everybody? How about this guy? What does it tell us? Yeah, b to the c equals q. Very good. Okay, now you can see b to the x is p times q, but the p is b to the a, and so p is b to the a and q is b to the c. But do you remember the exponent rule? Exponent rule say b to the a times b to the c is b to the, what do you do to the exponent? Do you multiply them or you add them? Add them, right? So this is a plus c. Yes. So we have b to the x equals b to the a plus c because they have the same base. So that means the exponents must be the same. So therefore, we have x equals a plus c. The exponents are the same. And that's why the x equals a plus c. So this is how we show the first rule. So far, so good, everybody? Okay, keep going. How about the second rule? Oh, by the way, this is Q. So let's call this as Y. So this means B to the Y is P over Q. Do you agree? Yes. And P, what's P? B to the A. Yeah? What is Q? B to the C. Yes, everybody. Oh, if we have b to the a divided by b to the c, this is b to the a minus c. Yes, everybody? Do you remember the exponent rule? B to the a over b to the c is b to the, so it's the same base, and then the exponents we subtract. Now, because this guy and this guy have the same base, therefore we have y equals a minus c. Okay, so y equals a minus c. And this tells us that the log break the products into sum. And the log break the quotient or the fraction into subtraction. Okay, so break the products into sum and break the quotient into subtraction. Is that okay, everybody? All right, keep going. How about the power? Okay, let's call this a z. So this tells us that b to the z is p to the n. Yes, everybody? But what is p? P is b to the a. So p is b to the a to the n. By the exponent rule, what's that? Multiply. You see, a times n. Oh, you see, b to the z equals b to the a times n. Because they have the same base, then the exponents must be the same. So z equals a times n. And this is a. So z equals a times n. Yes, everybody? So what does log do? Well, if we have a power on the p, okay, it brings the power down in front. Okay, so log break the products into sum. It breaks the quotient into subtraction. And it brings the exponent down in front. Okay, everybody? Okay, so those are the log rules. Now, how do we use the log rule? Okay, so two main use. One use is to condense the expressions into a single log with a coefficient of 1. Okay, simplify further. The other way is to expand the single log expressions into the sum or difference of simple log functions. Okay, so those are the two main uses of the log properties. Okay, now let's see. So first thing, what we do is make sure all terms, okay? So move all the coefficients so to the exponents inside the log, okay? So that the coefficients are 1, okay? So like here, do you see this is the coefficient is 2? So we move to the exponents. Then we have log 6. Bless you. So this is 2 square. Yes, everybody? So we move the coefficients to the exponents inside the log. Now, the coefficient of all terms are 1. So far, so good, everybody? Yes. And second, we combine. Okay? We can combine. Well, the sum become what? The sum becomes product or quotient? Products, right? The sum become products. So we have 2 square times 9. What's 2 square? 4. 4 times 9 is 36. Oh, do you see 36 is actually 6 square? Oh, do you see log 6 cancel? And we just get 2. Yeah, everybody? So log and exponential function, they are inverse function. So that's why log, b to the x is x, and b to the log bx is also x. So they can cancel because they are inverse function. Yes. Okay, keep going. Part B. We check. Are all the coefficients 1? Yes. So we can combine. Okay, it's the subtraction. So log change the subtraction. When we combine, we get what? Product or quotient? Quotient. So we have log 5. Combine them, become a quotient. Good. What is 50 over 2? 25. Oh, what's 25? Yeah, see? Oh, you can simplify. Okay. So, what is 16? 2 to the, what's 16? 2 to the 4. What's 81? 3 to the 4. Right? How about 64? 64 is 2 to the 6. Yes. Okay, very good. Okay, keep going. Okay, part C, check. Are all the coefficient 1? No. So we want to move this coefficient up there. So we have log. And by the way, if we see log, that means the base is 10. Very good. So log 4x minus 3 minus log of x squared. Yes, everybody? Okay. And be careful. The way you put the parentheses is really, really important. For example, so log x squared, this means 2 log x. Right, everybody? But if you have log x squared, you see, they are different. You see, the way you put the parentheses make it different. So this is log of x. And then raise the power square. And this is not 2 times log x. Okay, this is log x times log x. Okay, this is log x and times log x. they are not the same. So the way you put the parentheses, very, very important. Okay, when we combine them, what do we get? Quotient. So that's log of 4x minus 3 over x squared. So far, so good, everybody? A question. Is this equal to log of 4x minus 3 over log x squared? Are they the same? No, be careful. Okay, so we need to stick with the rule. And if the rule doesn't say, oh, we can split the quotient into quotient, then we cannot do that. So yeah, this is a case we cannot be creative. We have to stick with the rule. So this equals to the subtraction. And we know subtraction in general is not the same as the division. Okay, so be careful. And by the way, can I cancel this x and this x? No, we cannot do that. We can only cancel if it's like product, the factor form, we can cancel. Okay, in this case, this x and this x, we cannot cancel. So be careful. Okay. So that's why I hope you have a mistake book to collect all your mistakes, like from your homework or from your quiz or from the practice exam. And then before the exam, you can review the mistake book and then to remind yourself, oh, I made this error. So don't make this error again. Okay, so this is how I learned math. Have a mistake book, remind ourselves. Because think about it. Right before the final exams, we have learned a lot. We don't have enough time. Okay, maybe you can plan better, then you can review all the notes. But it's hard to. If I just give you one day, how do you review everything? And what do you want to do for the one day? Okay, maybe review all your mistakes, review all the practice exams, review all the quiz and the exams, the previous exams, right? So I would say the mistake book is very important. It can like remind ourselves, oh, this is the things I did wrong. So let me review that and make sure I remind myself, don't make the errors again. Okay, so don't be afraid of mistakes. They are our teachers and friends. They help us improve. Right. Okay, keep going. Now, part D, what do we do? Okay, so we want to combine them. Oh, it's 2 times this. Okay, so we can do the operation from the inside to the outside. So which means we can choose to combine these first and then move the 2 on top of everything inside the ln. Or you can distribute the 2 first and then move the power on top and then combine. Okay, so there are different ways to solve this problem. Which way do you prefer? We'll do the inside first. Okay. Yes. So 2 times. Okay. Let's make sure are all the coefficient 1? No, so we need to move them, right? So this is, oh, I don't need a big bracket. Okay, a small one will be enough. Ln x minus 1 minus ln x plus 2 cube. Right, everybody? And don't forget the parentheses. Because if you forget parentheses, it looks like ln of x plus 2 to the cube is like 8. So be careful with the parentheses. Don't miss the parentheses. And then minus ln of x plus 3 to the 4. Right, everybody? So, okay, we make sure all the coefficients are 1. Now we can combine them. So that is ln. See, we need a big parentheses. If the sign in front of the ln is positive, then you move this factor in the numerator. If the sign in front of that ln term is negative, then we move this factor in the denominator. Okay, everybody? Mm-hmm. So, yeah, write it down. If the sign in front is positive, move the factor to the numerator. If the sign is negative, move the factor to the denominator. Okay, so when you solve the type of problems, it's good to summarize. Okay, summarize the rule and summarize the steps, what we are doing in these steps. Okay, then when you see a different problem of the same kind, you know how to do it. Okay, so x minus 1, move it on top, and x plus 2 cube, moving downstairs. Right, everybody? How about this guy? Moving top or bottom? Bottom. Yeah, very good. So x plus 3 to the 4th. So far, so good, everybody? Okay, finally, these two, we can move to the exponent. Okay, so that is ln. And please simplify. So if you move to the exponents, that means if everything raised to the power 2. So when you want to write down like factor by factor, you want to distribute the exponents. So this guy to the power what? 2. And this guy to the power 6. Yes, distribute the exponents. And this guy to the power what? 8. Yeah, very good. So x minus 1 square, x plus 2, 6. X plus 3 to the 4. Sorry, to the 8. Thank you. See, sometimes I make mistake too, so I need to check my work. And you please help me to check my work as well. Yeah. Okay. Any questions about this problem? All good? Okay, keep going. Now we do the reverse. Okay, so we have a single law we want to express into a simpler law functions. So fully expand. Fully expand means we don't want to see any power. So each law just contains one type of factor. We don't want to see a product of two factors of quotient or quotient of two factors, right? Okay, first thing we do here. Do you see we have the power? What do we do to the power? Move in front. So this is 3 log of x minus 1, x plus 2, right? Okay. What do we do to it? Log break the quotient into subtraction. So x minus 1 subtract log of x plus 2. So far, so good. Everybody? Yes? Okay, good. Keep going. How about part B? Okay, so you do part B. get raised to the 1/4, right? So we have like x plus 1, x plus 2, raised to the 1/4. So we can move the 1/4 down in front. And then we can break them, right? So we can break them. So put a bracket. If the factor is on the numerator, then we add them. So add the ln of x, and then x plus 1 is on the numerator. So we have x plus 1. X plus 2 is in the denominator. So we subtract ln of x plus 2. Is that okay, everybody? All right. Okay, many calculators only handle base 10 and base e log. But what if an application requires a different base? This is the change of base formula we need. Okay? So we can use this formula to change to any base we want. Okay? So usually we love the base e. Okay? So we can change to base e. So log ax with the new base, the x stays in the numerator inside the log. But the old base now becomes in the denominator inside the log. Okay, everybody? So you can think of, oh, x is above the a. So you still put the x above, and you put the a below. Okay, everybody? So this works for all the base. So usually we just use the ln. So you can think of this as ln of x over ln of a. Okay? So x is above, a is below. Okay, now estimate log 13 of 66.3 using our calculator. So this is what? ln of what? 66.3, right? Over ln of 13. Okay, plug this in your calculator. What do you get? Yeah, thank you. Right, so round your answer to the nearest thousand. Do you get 1.635? Yes. So bring your calculator. Yes, from now on, please bring your calculator in class. Yes, this is you do application problems. Then you need a calculator. Okay? Make sure you are able to get these numbers. By the way, you have your phone. Do you know if you slide your phone this way, your calculator is like bigger, has more buttons? Do you know that? Yeah. I think you will see the LN. You cannot use yourself in the exam. But just now, if you forget your calculator, right? Let me make sure I can rotate my phone. So this side, you only see the basic one. When you rotate it, you can see the LN and LOG. Yeah, if you have an iPhone. How about your phone? Do you see this bigger calculator? Okay, yeah. All right. Okay, now, yes, we are able to solve this finally. Okay, remember? We say, oh, 2 to the x, but this is base 7, and we were not able to solve it, right? If we apply log 2 on both sides, we get something like this. So x equals log 2, 7. Now, because of the change base formula, this is ln 7 over ln 2. And what is that? ln 7 over ln 2. What do you get? Thank you. So approximately equals to 2.807. So far, so good, everybody? Okay. Yes, very good. So, how How about let's do a little bit more practice. So this is our practice exam. Okay, so take out a piece of paper. Do these two problems. So this is our practice exam. You can practice now, and then later on when you do the practice exam, you will forget what you have to do. Then you can redo it. So take out a piece of paper and write the answer. Oh, are you able to see? Let me zoom in. This is what you can do. Which is x plus 1 equals 2. That's okay, you can consider that as a factor. Oh, this calculator is not very good. It is not having time. You need to cut another. This will work. This one, so maybe need to be out right here. Oh, yeah. Oh, oh. If I think about this you can enter with a whole lot of enter. But this one, you have to enter step by step. Like 6, 6, 6, 6, 6, 3, and you put it out. That only give you the numerator. And then you have parity, then press down, and then give you the denominator. And then you have to go back to the previous number and divide it by this number. So my suggestion is and if you have touch, so this is one calculator. There's the T after the X below add Z. That is like 3 times. And those can be multiplied by 2. Yeah, try it, try it, try it. factor in the numerator. If it's minus in front, you can reject that. This is the log of, if this is plus, then you move this factor on the right. If it's minus, you move this factor in the numerator. Okay. Yeah, so I will let you to continue at home, okay? So this is on a practice exam. And we have a little bit time. Let's continue to look at 4.6. So now we have learned exponential functions and log functions and the properties. So we can help us to solve some inequalities involving the exponential function or the log functions. Okay, example 1. If we have the exponential term or the log term, the first thing we do is isolate it. So first thing, isolate the exponential term. That's the first thing. Okay, so here, how do we isolate the exponential term? Subtract 1 on both sides, right? We get 2e to the 12x equals 17, right? So isolate, what isolate means? It means you want to have the exponential term on one side just by itself, right, everybody? What do we do? Divide it by 2. Yes, so we want the exponent term to be by itself, so divided by 2. Now we have e to the 12x equals 17 over 2. Right, everybody? Okay, so this is how we isolate the exponential term. Okay, and second step, how do we get rid of the exponential term? We apply log on both sides. Okay, see, when we apply ln on both sides, we get ln e to the 12x equals ln of 17 over 2. Yes, everybody? We apply ln on both sides. Oh, what happened to your left-hand side? Do you see e, ln and e cancel? We get 12x. Yeah? So we can solve for x. So solve for x. Okay. What is x? What do? We both sides divided by 12, right? Okay, so this is x. The problem says find the exact solution. So this is the exact solution. And also approximates to the nearest thousand. So now you plug this in your calculator. Okay, so plug this in your calculator and what do you get? Exam 1, maybe you don't have to use your calculator. The exam 2, you must use your calculator. So please make sure to get a calculator, okay? And it's better to have, oh, may I borrow it? It's better to have this TI-30 multi-view because instead of just one line, it has 3 lines. And so this calculator is also good for the future classes like probability and statistics. Okay, so this is good. The multi-view, it has 3 lines instead of 1 line, so you can see more. Thank you. All right, so type this in your calculator. What do you get? Give me 3 decimal places. 0. Thank you. 0.178. Right, everybody? Okay. Let's see. We have some. Okay, so in some cases, it's easier to take the log of both sides than use the power rule. This is especially helpful when there are different spaces in the same equation. Okay. Yeah. Like this problem, example 2. Where we have both sides, we have the exponential term. So we apply log, okay? Our previous problem, we apply ln because this is base e. But do you see this problem? This is base 2, this is base 3. So let's just apply ln on both sides. Not base 2, not base 3, just apply ln on both sides. Okay, then we have ln 2 to the x equals ln 3 to the x plus 1. Okay, yes, everybody, we apply ln on both sides. Next, we can move the exponent down in front. So we have x times ln of 2 equals x plus 1. Be careful, be careful. Don't forget your parentheses. So it's x plus 1, this whole thing, multiplied by ln of 3. So don't forget the parentheses. If you forget the parentheses, it will be wrong. Be careful. Okay. Then what do we do is we want to distribute. Okay. So distribute. This is x times ln of 2. Here, distribute. So you see we get x times ln of 3 plus ln of 3 times 1 is ln of 3. Yeah? So step 1, we apply ln. Step 2, we distribute. Or you can say we expand. Okay, step 3. We're gonna move all the terms with x to the left-hand side. And move all the terms without x to the right-hand side. What is term? Term is separated by plus or minus. Yes, everybody? So does this term have x in it? Yes. So leave it on the left-hand side. Does this term have x in it? Yeah. So we need to move to the left. Does this term have x in it? No. Keep it on the right-hand side. So we need to move this to the left. So it's like we are subtracting it on both sides. Now do you see the left-hand side become x ln of 2 minus x ln of 3 equals the right-hand side is ln of 3? Once you move all the terms with x to your left-hand side, and then do you see left-hand side, x is a common factor. Do you see that? So factor out, so factor x on the left-hand side. What's that? Yeah, ln of 2 minus ln of 3. Yeah, what is x? Our right-hand side divided by this ln 2 minus ln 3. Yeah, everybody? So we factor the x on your left-hand side. And so your x will be your right-hand side divided by that. Yes, everybody? Okay, so this is the exact answer. Plug this in your calculator. What do you get? So be careful, the parentheses. You have a parenthesis down here if you want to include in your calculator. What do you get? 3 decimal places. Yeah, I'll try that on your calculator. What do you get? 92.710. Oh, thank you. Okay, so let's see you on Friday. Have a nice day.